Welcome to TNAV Tutoring. We are going to be doing some sailings problems today. So forgive me, but I am going to disappear from your screen and you'll be looking at my ceiling. So I have the problem, you depart latitude 28 degrees 35 minutes south, longitude 68 degrees 22 minutes west, for latitude 28 degrees 35 minutes south, longitude 55 degrees 48 minutes west. What are the course and distance by parallel sailing? So parallel sailings are the easiest of the sailings to work at, which is why we have started with them. So something I like to do first is give myself a visual picture of what's going on. So I will draw a little cross, and this is like my world map, a very simplified version. So we have our latitudes up and down. All of our northern latitudes will be up top, and all of our southern latitudes will be down here. And then we have our east and west. Our eastern hemisphere will be over here, and our western hemisphere is over here. And it's just something to help me wrap around my head on the problem to see what's happening. So we depart at a latitude of 28 degrees 35 minutes south and a longitude 68 degrees 22 minutes west. So we are starting in the southwest hemisphere. So that is this one that I've boxed. So 28 degrees south, you can say it's approximately there. And then it was 68 degrees west. So let's just put it out there to start. And then for the second half of the problem, our latitude is the same. So we are still at 28 degrees, 35 minutes south, but our longitude has changed to 55 degrees, 48 minutes west. So we're still in the southwest hemisphere, so we're still in this box. So because we have gone, so our western hemisphere, so our longitude has changed. It has become less. So that means our second longitude has to be between our first point and the meridian of 0. So let's put our second point right there. And I like to draw an arrow to see which direction we're going. And this just gives me a mental picture. So we have already answered what is the course by parallel sailing. Because the course for parallel sailings can only be either east or west. Because our latitude does not change no matter what for parallel sailings. And this only applies for parallel sailings. So in this case, we are going east because we have started here and we are going this way, same direction as the arrow. So our course is easterly or 90 degrees. Either is acceptable. So to determine our distance by parallel sailing, we'll use the formulas listed on the screen. So for this type of problem, we will only be using this formula. So D, or distance, equals D low, or difference of longitude, times cosine of L, or our latitude. So D equals D low times cosine of L. I always like to write the formula I'm going to be using on the phone because it's good to know when you're going back and looking for your notes to see, oh, I used this formula for this problem. So D equals distance between longitudes. So we need our latitudes and our longitudes written down. So 28, 35, 28, 35, and longitudes are 68, 22, and 55, 48. So we need to find our difference of our longitude. So 68.22 minus 55.48. I'm going to put that into my calculator. So I'm using the Casio calculator that some of you should have. 8 degrees minutes seconds button, 22 degrees minutes second button, minus 5 degrees minutes second button, 8 degrees minutes seconds button. And this gets me 12 degrees, 34 minutes west. You don't need this change of direction, so I normally leave it off, because our course is actually easterly and that might confuse some people. So our distance between our longitudes is 12 degrees, 34 minutes, times cosine of our latitude, which is 28 degrees, 35 minutes south. And you don't need to write the south when you're doing the math problem. This is very important to not round at all whenever you use cosine, sine, or tangent in any of the problems. So when I'm typing this into my calculator, I'm typing 12 degrees minutes seconds button, 34 degrees minutes seconds button, times cosine, parenthesis, 28 degrees minutes seconds, 35 degrees minutes seconds, close the parentheses. It is very important that you type it into the calculator correctly. This gets me 11 degrees, 2 minutes, 6.25 seconds. So we are not quite done yet. That is the distance in degrees. But that doesn't make sense to me and doesn't make sense to you, how far we're actually going. So we need to convert it into nautical miles. And that's simply multiplying it by 60, because 1 degree, 1 minute is the same as 1 nautical mile. So we're just converting degrees into minutes, and minutes equals nautical miles. $662.1 nautical miles is our answer. So you can go ahead and do the next problem, which is another parallel sailing. So with this problem, we're going to go through the same routine. So we are departing latitude 28 degrees, 35 minutes south, longitude 12 degrees, 22 minutes west, for latitude 28 degrees, 35 minutes south. Longitude 10 degrees, 48 minutes east. What are the course and distance by parallel sailing? So this problem, we are still on our world map. We are of a southerly latitude for the first half, with our longitude of 12 degrees, 22 minutes west. So we are here. And then for the second half of the problem, we are at latitude 28 degrees, 35 minutes south. So we're at the same latitude, so we're still right here. But our longitude is 10 degrees, 48 minutes east. So we're in the eastern hemisphere for this one. So we have crossed the meridian. We went from the west to the east, so we know our course is easterly, or 90 degrees. So we need to find the distance between our longitudes. So because we crossed the meridian, we do something a little different for this problem. We will be adding them instead of subtracting them. Try to answer why in your head or in your notes. Pause the video if you need to. So, why you have to add instead of subtract is because it's just like a number line. We have, and the meridian is 0. So we have numbers all up on this side, and we get up to 12, and then we have numbers all up on this side, and we get up to 10. We need to find the difference there, and then to there. So we know the distance between 12 and 0 is 12. And we know the distance between 0 and 10 is 10. But in order to get from this side to this side, we need to add those together. 22. And we're going to apply the same concept to our longitudes. So we have 12 degrees, 22 minutes, plus 10 degrees, 48 minutes. And that equals 23 degrees, 10 minutes. And this is the distance between your two longitudes. So that is the distance from here to here. And we'll plug it into the problem now. So D equals D low times cosine of L. So D equals 23 degrees, 10 minutes, times cosine of latitude, which is 28 degrees, 35 minutes. So we'll multiply our difference between longitudes, 23 degrees, 10 minutes, times cosine, parentheses, 28 degrees, 35 degrees, minutes, seconds, then, and that equals 20 degrees, 20 minutes, 35.39 seconds. And what do we need to do in order to convert degrees to minutes? or degrees to nautical miles. We did this in the last problem. Multiply by 60. So we'll take the 20 degrees, 20 minutes, 35.39 seconds times 60, 1220.59 nautical miles. And that is our final answer for this parallel sailing problem. So you may have noticed that we have not used this other formula. It's the same as this one, but it's rewritten so that you can use it when you don't have your second latitude or longitude. So for this problem, we'll be using that other equation. D low equals D divided by cosine of L. So in this problem, we depart latitude 45 degrees, 30 minutes north, longitude 78 degrees, 00 minutes west on a westerly course of 270 degrees for a distance of 885 nautical miles. What are the new latitude and longitude? So we have our T-chart for the world map. And we know this is a parallel sailing because we are on a course of 270, which is directly west. So we are starting in the northwestern hemisphere. So we can put a dot just about anywhere to just symbolize where we are at in the western hemisphere. And we are on a westerly course. So that's the direction we're going. So our latitude will stay the same. So we know our latitude is still 45 degrees, 30 minutes north, but our longitude will be greater or smaller than the current longitude. We may need to think about it. We are in the western hemisphere and we're going further west. So if we have our number line with our 0 there in the middle, and we are here at 78, and we get further away from 0, would the numbers get larger or smaller? They would get larger. So we're looking for a number that is greater than 78 degrees. We will start with our formula. D low equals D over cosine of L. So D low equals our distance of 885, which I got from the problem, and our cosine of our latitude, 45 degrees, 30 minutes. So calculated error is quite common in these types of problems. So it's 885 divided by the quantity, so you need a parenthesis, then cosine, which will give its own parenthesis, 45 degrees, 30 minutes, and you have to hit the parenthesis button twice in order to make it function correctly. Otherwise, you'll get an error message. And I got the number 1262.64 and some change. You want to leave that entirely into the calculator. So this number is in nautical miles or in minutes. How do we change that to put it into degrees? We'll divide it by 60. We're doing the opposite of what we did in the previous problems when we multiplied by 60. So we divide the number by 60, which equals 21 degrees, 2 minutes, 34.74 seconds. This is important to know that you do need the whole number. And this is our D low, so we're not done yet. So we have the distance between our two longitudes, 78 degrees, 00 minutes. Are we going to be adding D low or subtracting D low from 78? Remember, our number needs to get bigger. So we will add it. So we have 99 degrees, 2 minutes, 35 seconds. And this is our new longitude. And it's important to not forget your labels. So is this east or west? It will be west. And that is the end of the parallel sailing tutorial. Feel free to bookmark this and like it. Ask any questions in the comment section below. I will do my best to answer them.